Okay, so hello everyone. I'm Han Wu, and currently I'm a lecturer in cybersecurity from the University of Southampton. Actually, this project was awarded when I was still a postdoc in the University of Birmingham, and worked with a number of interesting colleagues on this exciting topic. So, simply speaking, we are collaborating with Advice Robot, a financial platform that provides advices for businesses. This company is based in Netherlands, and when we collaborate, we discuss about some risks in their business. So one risk arises in this so-called buy now and pay later service. So the company provides advices for companies who lend money to their customers, and they are facing significant risks in case that those customers failed to pay later. And the company want to build a machine learning-based prediction model to predict the likelihood whether the customer is going to pay later or not, based on their profile or some personal information. And this company has several branches across the world, in Netherlands, Mexico, and a number of countries in Europe. And the question is, sharing those data across borders is not easy, right? Because due to some policies or laws, you cannot directly just transfer the customer data from borders to borders. And to resolve this, our initial solution is federated learning, which allows the different branches of the company to train a machine learning model within its border and then transfer or transmit the machine learning model parameters only. So this is the traditional solution, centralized learning, where you have to transfer the customer's data from countries to countries. And this is not feasible for this country, but for this company, sorry. And federated learning provides a distributed solution for this case. And in our initial tests, the performance of the federated model achieves some acceptable performance, and this drives us moving forward to discuss about further improvements based on this framework. So is this privacy-preserving framework, federated learning, enough for the company? Well, the company raises another concern with regard to this so-called right to be forgotten policy. It was written in the GDPR. So in this case, whenever a customer intends to withdraw the consent with this buy now and pay later service, this company, Advice Robot, is supposed to eliminate or remove all the information relevant to this customer from the server, right? So this story, right to be forgotten story, also applies not only to private data, but also copyright data or secret information or other personal data. And the problem is AI models, machine learning models, they show some memorization capability of the personal information. So, sorry, it's not going to work. The next slide, yeah, thank you. So these are some recent research based on this story. So by conducting some advanced attacks on the trained machine learning models, you can literally reconstruct some private information related to the data that have been used in the training process. So you can conduct an attack on image classification data to reconstruct the facial information about the customer, or you can construct by injecting some prefix in the prompt words when interacting with large language models to reveal some personal or sensitive information used in the training data too. And next slide, please. So to address this, our intuitive solution is to leverage the idea of machine unlearning. So in the middle, it represents a typical workflow of machine learning training. And we split the training data in two parts, the retraining data and the unlearned data. So unlearned data refers to the data that is supposed to be forgotten by the model. And the most intuitive solution is to just retrain the whole model from scratch using this remaining data. However, this could be really ineffective because the unlearning request may arrives every day. And therefore, we should utilize, next slide please, some advanced unlearning algorithms. So this is usually based on some fine-tuning method, or you just trade the storage for time to save the cost and time to achieve unlearning. And the unlearned model should be as close as the retrained model as possible. And next slide, please. And in this project, we conduct some benchmarking tests leveraging the advanced unlearning algorithms based on our federated learning framework. And there are two cases we are looking into. First is instance unlearning, which corresponds to the case where customer withdraws the consent. And in this case, we need to remove the memory about a row in the tabular data. Next slide, please. Yeah, thanks. And the other case is the feature unlearning, where, for example, some regulator in a specific country bans some certain feature. For example, the marital status is not allowed to be used in the training process. And next slide, please. And here are some benchmark results. So we test our results on 3 metrics. First is the fidelity, where the model is still usable after the unlearning process. And second, next slide, please. Second is the certifiability, whether we actually achieved unlearning. And the third one, next slide, thanks, and the efficiency. Okay, so finally, yeah, we are continuing our research in the generative AI area. And both technology, federated learning and unlearning, is promising in the large language model area. So this is due to the large size of the data set used and the large size of the model. And a recent case where OpenAI has filed in the lawsuit against the German court due to the abuse of copyrighted musical information in the training set. And unlearning also can be applied in such cases to eliminate the memory of such sensitive or copyrighted information. And yeah, the research is this project has been accomplished months ago. My research is still in this relevant field, and welcome to have a chat in the middle. I don't know. Thanks.